Hello students, welcome back to chemistry class. What we were on to? We were discussing about the Haworth structure of glucose. Already we have done the Haworth structure of glucose in last class. Let's quick revision of that Haworth structure of glucose. Then we will continue today's topic. Haworth projection. Glucose structure: CHO, CH2OH, HOH, OHH, HOH, HOH. This is the structure of D-glucose because OH group right side on the farthest chiral center side is D-glucose. It's called D-glucose. What is this? D-glucose. Right, numbering from here 1, 2, 3, 4, 5 and 6. 6 carbons are there. Now, due to the presence of this carbonyl carbon, it is a planar in structure. Now CHO, the carbonyl carbon is a planar in structure. Now the lone pair of electrons of oxygen atom attacking on the carbonyl carbon. So nucleophilic attack takes place on the carbonyl carbon. This H plus attacking on carbonyl oxygen, or this pi bond shifted towards the oxygen atom. Clear? Here two types of compounds will form. In one case the OH group is right side. The first case is OH of the carbonyl carbon. Carbonyl carbon is called anomeric carbon. What is it? Anomeric carbon. At anomeric carbon or glycosidic carbon, OH group is right side. That is called alpha D glucose. Means H single bond is single bond OH, remaining as CH2OH. Okay, HOH, OHH, HOH and H. This is the alpha D glucose. Alpha D glucose. Why it is alpha D glucose and anomeric carbon? OH group on right side. This is called anomeric carbon. Anomeric carbon. Blindly we can remember this. Carbonyl carbon is called anomeric carbon, and anomeric carbon OH right side is so alpha D glucose. While we are writing the Haworth structure of Fischer projection of the glucose, the groups which are present on the right side we should write down. The groups which are present on left side we should write up. Okay, the CH2OH is always up. Okay, instead write the 6 member ring. How many member ring? 1, 2, 3, 4, 5, including oxygen 6 member ring. Instead we need to write that. This is the 6 member ring. Okay, 1, 2, 3, 4, 5 and CH2OH. On first carbon, this is the first carbon, numbering from carbonyl carbon 1, 2, 3, 4, 5 and 6. On first carbon, OH right side is there, right side means down. Okay. On second carbon, OH is left side is there, so up. On third carbon, first carbon right side down, second carbon also right side. Second carbon also contains right side down. Okay. Right side. Third one left side is there, up. Fourth one right side is there, down. And your hydrogens will come like this. Hydrogen and hydrogen. This is also hydrogen. Okay. Down, up, down. This is a alpha D glucopyranols. Okay, pyranols structure related to pyranose structures. Otherwise, you can write alpha D glucose. Haworth structure of alpha D glucose you can write simply. And for this, we can write the chair form. This is the chair form of alpha D glucose. Okay, this number 1, 2, 3, 4, 5 and CH2OH 6 carbon. On first carbon, carbon number 1, OH right side is there, so down. You should write down. On second carbon, OH right side is there, down. On third carbon, OH left side is there, up. And next carbon, I am giving number 1, 2, 3, and 4. Fourth carbon, OH which side is there? Right side, so down. Clear? And single bond H, and single bond H. Single bond H. Next, beta D glucose, this is right here. Beta D glucose. Beta means OH is left side on the anomeric carbon. CH2OH, HOH, 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 H. Go like this. 1, 2, 3, 4, 5, and 6. Clear? Now, left side there we choose it is a beta D glucose. Beta D glucose. Now, Haworth structure. 1, 2, 3, 4, 5, and 6. CH2OH, 6th carbon. And first carbon, OH left side is there, so up. And second carbon right side is there, down. And third carbon, OH left side is there, up. Fourth carbon right side is there, down. Okay. This is the Haworth structure of beta D glucose. I will let chair form for this. One, 2, 3, 4, 5, and 6. Okay. Now on first carbon, OH left side is there, up. On second carbon, OH right side is there, down. On third carbon, OH left side is there, up. On fourth carbon, OH right side is there, down. Remaining single bond H, single bond H, single bond H, single bond H. Okay, both are differs. Alpha D glucose, beta D glucose differs at anomeric carbon. Configuration at anomeric carbon differs. Remaining all are same. Remaining all are same. Here only at anomeric carbon the configuration of alpha D glucose, beta D glucose both are differs. Remaining everything is same. At alpha D glucose OH right side there and beta D glucose left side is there. That's it. Remaining everything is same. Clear? No doubt about it. Here down, up. Remaining down, down, up, down, down. Everything is same. What the difference? They differs at only anomeric carbon. So they are called anomers. What are they? Anomers to each other. Both are optical isomers. Pair of optical isomers which are differs at a C1 configuration is called anomers. Both are anomers of each other. Now, in this alpha D glucose and beta D glucose, in alpha D glucose at anomeric carbon OH is axial position. This is a at axial position is there. It is equatorial position. Equatorial position. Okay, OH group at equatorial position in beta D glucose, and in anomeric carbon OH group at axial position is there. Axial position down. Okay, axial position is there. So at anomeric carbon, the OH group at equatorial position, so it is a more stable. Beta D glucose is more stable. Chair form of this beta D glucose is more stable. More stable. This is a less stable. What is it? Less stable. When both are two forms of glucose, alpha D glucose and beta D glucose, when dissolved in water and wait a few minutes, two forms are formed. One form is converted to another form and equilibrium exists between two forms of beta D glucose, alpha D glucose and beta D glucose. Here, now when the two forms are dissolved in the water, beta D glucose, equilibrium with the open chain, it is equilibrium with the alpha D glucose, Okay, beta D glucose 64% and alpha D glucose 36% is present in the mixture. and this is 0.02 percentage is present in the mixture. Means open chain also exists. Means the beta D glucose is exists in the form of open chain. That is a very 0.02 form. Now which is more beta D glucose, because it is an equatorial and anomeric carbon OH group at equatorial position, so it is more stable. So 64% of beta D glucose is found in the mixture. So this is a more and this is a less form. Clear? Understand? Now the D form and L form of the same compound is mirror images to each other. D and L form of same compounds. D and L form of the same compounds are mirror images to each other. D form of glucose and L form of glucose. D glucose and L glucose both are mirror images to each other. Means they are enantiomers. What are they? Enantiomers. D and L form of the same compounds are enantiomers to each other. They are enantiomers. Means mirror images will form. Clear? Means we should write the groups which are present in the right side, we should write left side in the another form. For example, D form contains the right side OH groups. For example, OH groups are R, right side is there. We should write left side. Then both are converted as a mirror images. Clear? Let's take an example group, then you can understand easily. CHO, CH2OH, HOH, 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 HOH. What is this? D glucose. D glucose. And mirror image. Make a mirror image. CHO as it is and CH2OH also as it is. Now the groups which are present right side we should write left. OH and H. Here OH left side, there we should write right side. HOH. Here both are right side, there we should write left side. OH and OH. This is a L glucose. L glucose means D form and L form both are mirror images to each other. Mirror images to each other. They are called enantiomers. What are they? Enantiomers. Here. Next structure, fructose. CH2OH, C double bond O, CH2OH. Okay. OH left side, remaining 2 are right side will come like this. Okay. Number in the carbon atoms 1, 2, 3, 4, 5, 6. Clear? Name of this compound, IUPAC name of this compound 1, 3, 4, 5, 6. Pentahydroxy hexane 2-one. Pentahydroxy hexane 2-one. Clear? That is the IUPAC name of fructose. Clear? Now, in this structure, the OH group present at right side on the farthest chiral center. Right side on the farthest chiral center. So that's why it is called D fructose. Now, at farthest chiral center, OH group is on right side. So it is a D fructose. Now these lone pair of electrons are attacking on the carbonyl carbon. Attacking on the carbonyl carbon. And this hydrogen attacking on oxygen. We will get two types of structures. Okay, they are C single bond OH and left side CH2OH. CH2OH single bond CH2 and here OH H HOH will form, and between carbonyl carbon and terminal carbon linkage will form. Ether linkage will form. Clear? This is CH2O. Now how many members ring will form here? This is one ring 1, 2, 3, 4, 5, 6 member ring including oxygen. So number start from this carbon 1, 2, 3, 4, 5 and 6. Write the 5 members, 6 member ring. This is the 6 member ring here. Number start from CH2OH. Now we will get left side. The left side is after you should write, that is CH2OH. This is the number 1. This second carbon. Now on second carbon CH right side there, so OH is coming. On third carbon, this is third carbon, 3, 4, 5 and 6. On third carbon which left side there, so up will come, hydrogen coming down. And fourth carbon which right side there, so down will come, hydrogen is coming up. On fifth carbon which right side there, so down will come, H. On sixth carbon 2 hydrogen atoms are there, hydrogen atoms, acid atom. This is a alpha D glucose because OH group is present on alpha D fructose. OH group is present on right side at anomeric carbon, carbonyl carbon. So that is alpha D glucose. Now this is a Haworth structure of alpha D fructose, not glucose, sorry, fructose, alpha D fructose. Clear? Similarly, we will get one more structure here, that is a OH group coming left side. OHC single bond CH2 OH CH2 ether linkage forming here, and OH HOH remaining all are same. This is a beta D fructose. Why it is beta D fructose? On the anomeric carbon OH groups left side there, now all beta D fructose and alpha D fructose both are anomers each other because at anomeric carbon OH groups are differs. One having right side, alpha D fructose having right side, beta D fructose having left side. So both are anomers of each other. Okay, what are anomers? Pair of optical isomers which are differs at anomeric carbon. The configuration differs at the anomeric carbon. So they are called anomers. The beta fructose, beta D fructose, alpha D fructose, both are anomers of each other. Let's write the Haworth structure. How many member ring initially? 6 member ring will form like this. Okay. Now first carbon, this is the first carbon, 1, 2, 3, 4, 5 and 6. Now first carbon having right side, so CH2 OH will come down because it is right side, the right side down. Left side up. Left side which one is there? OH group is there. OH group right H is. OH group right H is. This is the 1, 2, 3, 4, 5, 6 carbon. Now on third carbon. This is the third carbon. On third carbon OH group left side is there. Left side means up and down. Now fourth carbon OH right side there. Right side means down. And at fifth carbon OH right side there. Right side means down. On sixth carbon 2 hydrogens are there, hydrogen and hydrogen. These two are differs at this is a beta D fructose and alpha D fructose both are differs at only at anomeric carbon. They differ only at anomeric carbon. Remaining everything is same. Okay, here up is there, down is there, down is there, hydrogen is there. Everything is same. What's the difference? They differs at carbonyl carbon, anomeric carbon. So both are anomers of each other. When the terminal OH group involves the ring formation, they will get 6 member ring. For example, on fifth carbon OH group is involved in the nucleophilic attack, we will get 5 member ring, that is a furanose. We will discuss now. See here, this is a CH2OH, C double bond O, CH2OH, OH, H, OH. What is this? Beta D fructose. What is it? Beta D fructose. Now, the lone pair of electrons of this oxygen involves in the nucleophilic attack. It is attacking on the carbonyl carbon. Now hydrogen attacking on the oxygen atom. Then we will get 5 member ring. Number in the carbon atoms 1, 2, 3, 4, 5, 6 carbons. Clear? How many carbons are there? 6 carbons. Now write C single bond OH, single bond CH2OH, CH2OH as it is. Okay, OH group and H group, H and OH as it is, H single bond and forming ether linkage to the carbonyl carbon. How many member ring will form? 1, 2, 3, 4, including oxygen, 5-membered ring will form. How many member? 5-membered ring will form, and which group on right side? So alpha D fructofuranose. Furanose, clear? Furanose, clear? Now how many member ring will form here? 5-membered. Write the 5-membered ring over oxygen. Now numbering start from here. 1, 2, 3, 4, 5 and 6. 5. Okay, clear? Now adjacent this oxygen having oxygen bearing carbon is the second carbon. Second carbon contains CH2OH and OH is there. OH right side is there. Okay, this is the first and second, third, fourth, fifth and sixth carbon. Sixth carbon having CH2OH. CH2OH. Clear? Now on third carbon, this is the third carbon. Left side is there. Left side means up and single bond is. On fourth carbon, right side is there, down and up. Hydrogen is there. And fifth carbon already over. This is the alpha D fructofuranose structure. Similarly, left side you will write one more structure, that is a C single bond OH. OH group on right side. OH group on right side means what is it? Beta D CH2OH OHH HOH H. So this is the beta D fructofuranose. Beta D fructofuranose. Numbering 1, 2, 3, 4, 5 and 6. How many member ring will form? This is initially beta D fructofuranose. Here fructofuranose. Now write the structure. Okay. Now adjacent to this oxygen second carbon. Second carbon. First carbon coming from CH2OH. Right side there. Right side means down. CH2OH and OH is up. So this is the third carbon, fourth carbon, fifth carbon, sixth carbon having CH2OH isis, CH2OH isis, sixth carbon. So on third carbon OH left side, the left side means up. On fourth carbon right side there, down. On fifth carbon CH2OH. This is a beta D fructofuranose. Clear? Now both are anomers of each other. They differ only at anomeric carbon. They differ only at anomeric carbon. Remaining everything is same. Okay, third carbon OH upside is there, upside is there. Fourth carbon down is there, down is there. Fifth carbon CH2 is there. Everything is same. What are the difference, sir? Only the difference is at anomeric carbon, carbonyl carbon, glycosidic carbon. So both are anomers of each other. Clear? This is about the Haworth structure of fructose.